Okay, here we go. Today I want to go ahead and just review for the Unit 3 solo quiz, which will go over 3.1 and 3.2. 3.1, conditionals and counterexamples. 3.2, conditionals and their related statements. So, to recap 3.1, conditionals and counterexamples, basically, conditionals are in the form if P then Q, or P implies Q, where P represents the hypothesis and it's the phrase after the word if, and Q is the conclusion, which is the phrase after the word then. Counterexamples, by the way, when we're trying to come up with the counterexample, you have to assume that the hypothesis is true, and you're going to use that hypothesis and look at the conclusion and disprove that conclusion, okay? And I know this probably doesn't make sense. I feel like this one can be a little difficult, but I will go over some examples so that we can get better and get confident in providing those counterexamples. Okay, let's go ahead and take a look at some examples. Identify the hypothesis and conclusion. Underline the hypothesis once and the conclusion twice, and state whether each conditional is true or false. If false, give a counterexample. So I have number 1 here. It says, if an animal is black and white, then it is a zebra. Okay, so I need to underline the hypothesis once, and it's after the word if, okay? So an animal is black and white. I'm going to underline once right there. I might as well use a different color. So here, I underline the hypothesis once, then I'm going to underline the conclusion twice. And usually the conclusion here is after the word then. So an animal is black and white is my hypothesis. It is a zebra is my conclusion, in which I underline twice right there. Now, I need to take a look at this, and I need to see whether the conditional is true or false. So basically, I need to look at the hypothesis, I need to look at the conclusion. If an animal is black and white, does there exist an animal that's black and white? Yes, I can think of so many animals right now. So I can say that this part is true. Okay? And then after that, I'm going to use this to look at the conclusion. If an animal is black and white, which is true, then does that mean it's a zebra? Now, I want you to stop and pause right there and think. So if an animal is black and white, is it always a zebra? No, because I could think of a cow, because, a cow can be black and white, because, look up a cow. So here, this is what I'm trying to say. With counterexamples, you're going to assume that P is true, which we did. This is true. And then you're going to go ahead and disprove Q. You're going to provide me an animal that isn't a zebra, but at the same time is black and white. And my counterexample with that would be a cow. Okay, a cow. All right. Let's take a look at number 2. If an angle is greater than 90 degrees, then the angle is obtuse. Okay. Remember, we need to go ahead and underline the hypothesis once and then the conclusion twice. So the stuff right after if should be my hypothesis. So I'm going to underline this phrase here, an angle is greater than 90, just once. Then the stuff right after then, the angle is obtuse. That's going to be my conclusion. Just going to underline twice there, okay? So, now that I have that, now that I got that out of the way, I'm going to take a look at the conditional statement itself. I'm going to see whether or not the conditional itself is true or false, and if it's false, give a counterexample. Number 2, if an angle is greater than 90 degrees, then the angle is obtuse. So, can an angle, if I take a look at the hypothesis here, can an angle be greater than 90 degrees? Like, in general. If I'm looking at this hypothesis, is this true? I am taking a look at if there's an existence of this. Yes, an angle can be greater than 90 degrees. So I can say true for the hypothesis. Now that I have the hypothesis, does that imply, if an angle is greater than 90 degrees, does that imply that the angle is obtuse? Yes, it does. So that is also true. And the fact that, remember, this is a definition of an obtuse angle. If an angle is greater than 90 degrees, then it implies that the angle is obtuse. Or if I were to say the converse of that statement, if an angle is obtuse, then that means that angle is greater than 90 degrees. Okay? So please know this example in general, and 2, know that since you have a true here and a true here, what does that mean for the conditional? Is the statement, is the sentence, is this whole thing true in general? Yes, so the conditional is true. And by the way, I should write the conditional for number 1 is false, okay? Because we had a true and a false. So that should be an F right there, okay? So yeah, now let's go ahead and take a look at number 3. If x squared is equal to 144, then x is equal to 12. Can x squared be equal to 140? Oh, first of all, let me go ahead and just, this is the hypothesis, and then this is my conclusion. Okay, so now let's go ahead and go back to number 3. What I was trying to say is that can x squared equal 144? Absolutely. So that is just true. Like the hypothesis, I'm just going to assume true, and then I take a look at x is equal to 12. Okay, so take a look at this. Then does it imply that x is equal to 12? So if I plug in 12, right? If I plug in 12 for x, so 12 squared, well, 12 squared is the same thing as saying 12 times 12, right? So that's 144. But I need to go ahead and read the statement again. If x squared is equal to 144, does it imply that it's just x equals 12? Like, simply, is this the only x value that'll satisfy this equation? No. Because if you recall from Algebra 1, y'all, remember, you can say, let x be a negative 12, right? And remember, when you're replacing that x, you got to use that parentheses, okay? So negative 12, the quantity squared. What is negative 12, the quantity squared? Well, if over here, if I look at this, 12 squared is the same thing, 12 quantity squared is the same thing as saying 12 times 12. And then over here, since I have these parentheses and it's raised to the second power, I am talking about this whole thing being squared, that negative 12 itself, right? Negative 12, the quantity squared, is essentially saying negative 12 times negative 12, and that negative times a negative is a positive, so x can be negative 12. Okay, so what is this, by the way? You're wondering, what the heck is this? This is my counterexample. Okay, we understand that this statement here is true, but this statement here is false because it is not always x equals 12. Therefore, I can provide that counterexample, x can be negative 12, to disprove this statement. So the conditional of this is false. Okay? And the conditional of that is false. Let's go ahead and take a look at this one. This one's different. This one's pretty short. Identify the hypothesis, underline once, and the conclusion, underline twice. 16-year-olds are eligible to drive. This is from one of your notes here. Basically, this is not in the form if and then. But I'm going to go ahead and underline the hypothesis, even though there's no if, and I'm going to underline the conclusion, even though there's no then. So, 16-year-olds are eligible to drive. So this is basically saying, oh, this is what I have to be. I have to be 16 in order for me to drive. Okay, so this is, I'm just underlining once for 16-year-old, and then I'm going to underline this twice, because I can rewrite this, y'all. If you are 16 years old, then you are eligible to drive. Okay, and then, okay, look at this. You are 16 years old. You underline once. And then you are eligible to drive. which you underline twice. Okay, hopefully that makes sense. You can see that connection between the two. So this is not written in the form if and then, but I'm going to rewrite that so it does. So here you have it. Okay. All right. So in 3.2, the conditionals and the related statements. We talked about the negation, and the negation is basically this symbol here, is the squiggly line. It makes the statement opposite. It makes that statement opposite. So here, we talked about the conditional, especially in 3.1. It means if P, then Q. And the converse of that statement is just these two swapped, okay? It's if Q, then P, okay? Then the inverse of that conditional is you're going to use the negation for P and Q. So therefore you get not P, then not Q. Okay, and the contrapositive is you're going to, it's like the converse, but you're going to add the negation. So you're going to swap the P and the Q, and you're going to add the negation symbol to both of them. So it's not Q, then not P. Okay, so these are the things that you're going to have to memorize. It's going to be on you to know the difference between the conditional, the converse, inverse, and contrapositive. Okay, so now let's go ahead and take a look at all this. There's a lot going on over here. It says, write the converse, inverse, and contrapositive of the conditional statement. State whether true or false. If false, give a counterexample. So you're going to be presented with a conditional statement right here. If an angle measures 30 degrees, then it is acute. Okay? You're going to look at that statement and you're going to determine whether it's true or false. And if it's false, you're going to give a counterexample. So, if an angle measures 30 degrees, then it is acute. Well, can an angle measure 30 degrees? Yes. And if it measures 30 degrees, does that imply, so first of all, let me go ahead and say yes to this. This is true. The hypothesis is true. An angle can measure 30 degrees. That's awesome. So now, if an angle measures 30 degrees, does it imply that that thing is acute? Yes. So it is, so this right here, it is acute. That's also true. So since I have a true and a true here, you will mark true and you don't have to give a counterexample because it's true. The converse of that statement, okay, so first of all, this is the conditional, right? This is the conditional. It's in the form if P, then Q. The converse of that statement is essentially if Q, then P. So you're going to look at this statement here and you're going to rewrite it. So it's going to be this. If it is acute, then the angle measures 30 degrees. One second. I'm going to go ahead and pull up my notes real fast. So if it is acute, then the angle measure is 30 degrees. Okay, so here, can an angle be acute? Yes, absolutely. So an angle can be acute. But if an angle is acute, does it imply that the angle measures 30 degrees? No. And the reason being, and I'm going to rephrase this, if it's acute, does it strictly mean that the angle measures 30 degrees? Absolutely not, because here's my counterexample. We're going to assume that the angle is acute, okay? I'm going to provide a counterexample where something has to be acute, but it doesn't have to be 30 degrees, and I can say 45, y'all. 45 degrees. Is 45 acute? Yes, because it's less than 90 degrees, and this disproves that conclusion there. So I assume that this is true, but I need to take a look at this and use that to make it an idea about this one. Is this always true or always false? And in this case, it's false because I just provided a counterexample. Okay? So since this is true and this is false, that means the conditional. That means the conditional. So I would write T or F is false. Okay, and your counterexample would be 45 degrees. All right, the inverse. Okay, the inverse, that would be if not P, then, sorry, wrong symbol, not Q. So I look at I don't want to look at this anymore. I want to look at this. I'm going to say, okay, if it's not P, then not Q. I would say if an angle does not, because that's what the negation is. That means to make the statement opposite. If an angle does not measure 30 degrees, then it is not acute. Okay, and now is the conditional true or is it false? If it's false, provide a counterexample. Okay, that's if it's only false. Okay. Let's take a look at this. If an angle does not measure 30 degrees, does it imply that it is not acute? Okay, so here, an angle doesn't have to measure 30 degrees. That is true. Okay, so this thing here is true because an angle doesn't have to measure 30 degrees, but now I have the hypothesis. This is my conclusion right here. Does it mean, so if an angle does not measure 30 degrees, if something does not measure 30 degrees, then does it mean it's not acute? If something is not 30 degrees, so it can be anything but 30 degrees, does that mean it is not acute? So this is false because I can provide a counterexample, right? And I'm going to say 45 degrees again. Okay, so let's look at this. So if an angle does not measure 30 degrees, which is 45, so if it's 45, does it mean it's not acute? No. It means it is acute, right? So this statement is false, and therefore the conditional statement is false. Okay? All right, here we go. I think hopefully that this here and this here made sense. It really is just a matter of you just reading the sentence and trying to comprehend what the heck is going on over here, okay? I know this is a math class, but math and English do intertwine at some point or more. Here we go, contrapositive. So the contrapositive of this conditional statement that I'm still using, okay? Now I don't need to look at these anymore. I'm going to look at the conditional statement that it gives me. My goal here is to write the contrapositive, which is in the form, if not Q, then not P. So I would write, if an angle is not acute, okay, I'm flipping and then writing the negation. If an angle is not acute, then its measure is not 30 degrees. So looking at this, is the conditional true or false? If false, provide a counterexample. Okay, so if an angle is not acute, can an angle not be acute? Yes, that's true. That's fine. Does that imply that its measure is not 30 degrees? Well, if an angle is not acute, y'all, then of course it's not going to be 30 degrees. It can't be 45. It can't be 65. It can't be 78 if I wanted to. So if an angle is not acute, it does mean that it's not 30 degrees. Okay? So that is absolutely true. So therefore the conditional is true. And I don't need to provide a counterexample. Okay? Alrighty. Good luck on your quiz.